Okay, so this is the unit about transformations. And if I wanted to take this circle here and transform it, and if I did this to it, it would move it 4 to the right, 3, careful, down or up? Up. But I thought we trust the Y's. Usually we do because they're on the outside. Is this on the outside? No, so therefore you don't trust it. So it seems like it's down, it's actually up 3. And then this would not have a radius of 25, it would have a radius of 5. All right, so if I asked you to take this and move it to the right 3, you should have said x minus 3. The y I didn't say anything about. And then what do we want a radius to be again? 5? All right, so then you put 5 squared or 25. This making sense to you about circles? All right, next question about circles is, what if I actually do this, and I've moved it to the right 4, and I've moved it up 3, and it has a radius of 5, then, wait, did I make it? I don't think I made it big enough. Hold on just a second here. And I moved it to the right 4, so then it would actually go to there. So it'd be something like that. Now would you please debate with the person next to you what the domain of the circle would be? You can tell from this info what the domain should be, which is how far left and right it should go. And then you might even debate how you should write it. Because if you figure out it's like, I think it's -3 to 7, well then, you got to write it correctly, okay? Compare answers on the domain of this circle. All right, Odin, what do you say it is?
I don't really know.
All right, how far to the left does it go? What's the furthest left that my circle goes? I'll give you a hint. It used to have its center right here, but it moved to the right 4. But it has a radius of 5. Do you get this is to the left of the y-axis? So, can you get it or no? What's the furthest left to go? Somebody help them. -1 is the furthest to the left that the circle goes. Why? Because this is 4, and we know the radius has got to be 5, so it's got to be 1 more. So -1. Okay. What's the furthest to the right that this goes? Well, this is moved over 4, and if we go 5 more over because of the radius of the circle, do you get that this is 4 plus that would be 5 and make that 9? And if it went from -1 to 9, do you get that's a total of 10? And if that's 2 radiuses, that kind of makes sense, doesn't it? All right. -1 to 9 would be the domain. I'm going to give you another one since you guys were pretty terrible at that. I'm going to give you another one. How about if I had a dot right there and I said that the radius of this is at 5 right here, the center, and the radius is 2. What's the domain of this? Should be easier this time after a little reminder of how domain works. All right, compare with the kid next to you. What do you think it is? Yes, the domain would be, go back 2 spots this way to 3, 2 spots that way to 7, 3 to 7. Raise your hand if you had 3 to 7. Okay, awesome. Then what's the range? What's the lowest it would go?
-2.
-2. What's the highest it would go?
2.
Yeah, 2. -2 to 2. The range would be -2 to 2. Why are those brackets again? Because brackets means that it would touch them. You use, like, when you put an infinity on something, you'd never touch infinity. You'd use parentheses around an infinity, for an example. All right, so there's domain and range of circles. Now, you have a little Schoology quiz on circles. It's just a few questions long, but now that I just explained them to you, it'll be fresh in your mind. I want you to take a minute right now, go to Schoology, find the Schoology quiz about circles, and do it. I'll pause, and like 5 minutes later, you'll be done. And then I'll give you another little mini lesson, and then you'll have a Schoology quiz about that stuff. Okay, so go do the circles Schoology quiz. I'll pause while you do that. What's the rest of the assignment about today? It's about moving functions, and for instance, there's an inside and an outside in every function, and I'd like you to start by writing hi vo, and then copying this, and hopefully you'll remember what hi vo actually means, and then maybe that'll help you use the right words to say, this one's got a horizontal this and a vertical that. And it's got to stretch, it's got to reflect, it's got to move to the left, move to the right, or moved up or moved down. All right, so what does the HI stand for? Andrew, do you remember? Horizontal? All right. Horizontal is on the Odin? Inside. Kanafala. Can you do the vo? Vertical's on the outside. Very good. But the debate on this one will become, is that negative there on the inside or the outside? Talk to the kid next to you. What do you think? I'm hearing about half and half. That's why I brought it up. So on some of your functions, it's really obvious. Like if this was like this, you'd say, well, of course the negative's on the inside. There's only one inside, okay? But when the negative is in a fraction like this, you need to know that that's the inside. So that negative is not on the inside. And now that should inform you what 3 things you could say. Since the negative's on the outside, it's a vo. It's a vertical because it's on the outside. So that negative was a vertical something. And then that 8 is the inside. And so you should know what happens on the inside. What are your 3 things? Garrett, what do you think the 3 things are? It's been moved 3 different ways. Okay, there is not a stretch. Thank you for trying.
It goes to the right.
Okay, right 8 is one of your 3 things. Can you do the others?
It goes up 7.
Up 7 is correct. How about the V thing?
It has a vertical reflection.
Vertical reflect, very good. Now, some people like to say reflected over the blah axis. You can do that. Vertical. I'm going to just draw an X and Y axis, and I hope you'll be able to tell. If I say it's reflected vertically, then it's reflected up and down, so it's over which axis? The x-axis. Vertical means over the x. If you need to write that down, if that's not making sense, write it down. Vertical means over the x-axis. Okay. Now, the next kind of problem I want to talk over with you is, let's say I told you we're going to do absolute value of x, but we're going to do 3f of 2x plus 1. Can you put these 2 together into one equation that you could graph? I don't need you to graph it yet. That'd take too long. Can you just mush those 2 together into one equation that's been moved this way and that way Uses an absolute value, of course. Tease. Starts with y equals. What do you think?
3F.
Except we don't want to have the f there anymore because we know what the function is. See, you put f when you don't know what the function is, but we know what the function is. It's absolute value.
So the absolute value of 2x
Keep going.
plus 1.
There it is. That is those two put together into one equation. You see what happened? F stands for function. And I know what the function is. It's not an x squared or any of the other functions. It's the absolute value. All right. So what are the steps for graphing this then? Well, would this have any asymptotes? No. That's only the 1 over x kind that has asymptotes. Okay, so this is just a regular equation. And if you forgot, like, I don't remember what that looks like as a graph, that's totally fine. If I ended up making a whole bunch of dots and they look like this, you'd go, oh, it's a V shape and it's been moved. See what I'm saying? You just need enough dots. So, would you please make me 4 points? Any 4 points. Hint, pro tip, start by making the inside be small. Because see, if you make a big number on the inside, then you end up multiplying it by something else, and it gets really, really big, probably too big a graph. So, try to make the inside small with the numbers you pick. All right, Laney, for example, I bet you put in 0, didn't you? Oh, maybe not. All right, you could have. Take a second and walk it through with me. If I put a 0 right here, what would I get on the inside? Times the 3 plus the 1. There's 0, comma 1. Tommy Boland, what number did you put in?
I also put in a 0.
Excellent. What else?
Um,
All right, we'll do 1 together. Put in 1 with me. 2 times the 1 makes? You can do this, Tommy. Okay, and then what?
and then plus 1
Nope.
times 3 first.
Times the 3 first, and then that would make...
7.
All right, 6 plus this 1 makes 7. 1 comma 7. Who had 7? All right, good. Then we're going to put in 2. Max, put in 2 with me. 4 times 3 is 12, plus 1, 13. That got kind of big. Could you have put in -1? Absolutely. If you had put in -1, you'd have 2 times the negative 1. It's -2. Absolute value, that makes 2. 2 times 3 is 6, plus 1 is 7 again. And if you actually graph these, 0, comma 1, over 0, up 1, over 1, up 7, over 2, up 13, to the -1 and up 7. Aha! I can see where the V is now. See what I'm saying? Now, some people would make a mistake and they'd only graph like these 3 points. And then they would draw a straight line through it and say, there's my graph. No, it's a V shape. You got to know that the absolute values are V shapes. So how are you supposed to know that? I'm going to give you a very quick reminder of the 6 graphs that you have to know. You do not have to write these down. But if there's any of them that you sit there and go, I don't know what that is, then you should probably write it down. Do you know what this one is? If you're like, I don't know what you're talking about, then you should write it down. It looks like this. It goes through 0, 0, and it has like a 45-degree angle. All right, do you know what this one is? It's one of the big 6. If you know what letter it says, say it. V. It's a V shape. Okay, how about x squared? Do you remember what letter that would kind of make? A U shape. Good. Okay. How about the square root of x? That's not a letter at all. Can you picture that one? Do you know what that one looks like? Ah, a couple people drew it in the air with their finger. That is absolutely correct. It looks kind of like that. Okay. And how many is that? That's 4. And then there's y equals 1 over x, the trickiest one. The only one with asymptotes. Do. Dot here, asymptotic behavior in both directions. Gets closer and closer to the asymptotes, but never touches them. Can anybody name the last one? X cubed, very good. Do you know what it looks like? It's probably the least used, so I wouldn't be surprised if you didn't know. And if I just do this, it looks very deceiving. It's like it's going to be a straight line, but it's actually going to go way down here and way up there. So, oh, I just did that terribly. It's kind of like a parabola going up that way and a parabola going down that way. There we go. Okay, there's the big 6. So if you see a graph that looks like this, x to the 3rd, but minus 4, well, then you can know, well, it's like this guy, except he's moved down 4. So you should kind of know what they should look like when you're done. That'll keep you from by accident only graphing these 3 points and going, I don't know what it looks like. You know, if you graph the rest of them, you'd have one up here and one down there, and then it would be more clear about what it looks like. But sometimes if you only have a few of the points, you're not getting the big picture. Okay, next thing. There's a type of question where we say, here's a mountain range. And then we say, take these points. If this is f of x, I want you to do this to it. 3f of 2x. And then you're supposed to graph what comes out. You might even be smart enough to know it's vertically stretched, factor of 3. Now, let's be careful about this because that one's really tricky. Like I just said the 3, which was vertical stretch by a factor of 3. Take a second and just write this down and tell me what is that inside thing. That's something we test on. What's happening there? It is not vertical stretch by a factor of 3. What is it? Talk to the kid next to you. What is that one? A close but wrong answer is horizontal shrink. They were right so far by a factor of 2. So close. It is a horizontal shrink. But by a factor of what? 1/2. Very good. Okay. So if I were to take these points, and I will tell you what those points are, and put them in an XY chart, the way you should do this is to take the original points and do something to all the x's and something to all the y's. All right, so if I say that those 1, 2, 3, 4, 5 points are this, -2, 0, 2, 4, 4, 1, 8, 4, and 10, 0. That's what you'd do. You'd make a list of the starting points, and then you'd do something to all the x's, and you'd do something to all the y's, but be careful. Very easy to, like, oops, do the wrong thing, especially to the x's. All right, take a second. Figure out what to do to all your x's and all your y's. Because we're trying to do this to it. Pausing for a second. Okay, let's just make sure you're not doing it all wrong. That 3, you should be multiplying all the y's by that. Because that's on the outside, and the y is the up and down, which is the outside stuff. So this is times 3, times 3, times 3, times 3, times 3. That was the easy part. You do not times all the x's by 2. You divide all the x's by 2. Because it's the opposite of what you would think. Divide all the x's by 2, or multiply them by 1/2. Does this make sense to you? And then you would graph the resulting points. And the thing would look 3 times taller and not twice as wide, half as wide. So the M would get way narrower, but taller. Okay. All right. There's one last thing that if I didn't mention it, it would be pretty bad because graphing is a huge deal on this test. On the final, there's like 50-some questions. It's going to be a lot of questions. There's a bunch of multiple choice. Not all multiple choice, but a lot. But there's a bunch of graphs, and you won't have a graphing calculator to do them. So how are you going to do the graphs? Every single one of them can be done if you know how to make an XY chart. So I'm going to make the point. You don't know what I'm about to graph looks like. You have no idea what that graph looks like because it's a mix of an absolute value and a 1 over x graph, and it's being squared, right? Nobody knows what that thing looks like. But you could all graph it. You would just need to find some points. And you might be like, well, but when I put in 0, I don't get anything. That's because there's an asymptote. Do you remember the kind that have 1 over x? So if you put in 0, you aren't going to get anything, are you? Because it's a vertical asymptote. Then you could put in some other numbers, and every other number you'd put in would give you something. All right, so take a second and find me a bunch of points that would be on this graph. Because finding points is huge. Out of the first semester, I betcha that I told you about making points on a graph like this at least 30 times. So duh, it's going to be on the final multiple times. Pax, tell me a point that you know worked.
2 gave me 1/4.
2 1/4. I agree 100%. Tanner, give me a point. 3 1/9. There's another point where we could get nice whole numbers. What'd you get?
1.
And gave it you what?
1.
1 1 is correct. Any others that gave you nice clean points? Johnson. Negative 1 1. Excellent. Do you get if we make enough dots, you'll figure out where the graph is? That's really all there is to it. Just make more dots. If you can't figure out what it looks like, make more dots. All right. So finding points on a graph is really, really valuable skill. Now, sure, I'd love for you to memorize all of those 6 graphs and where all of its parent points are. That would be cool. But you don't actually need it because this would work. All right. So if, for instance, don't write this down, just listen. If, for instance, you had to graph this, I'd want you to know both things. I'd want you to know, oh, it's a V shape. Did you know it was a V shape, like right away? Cool. It's a V shape that's been moved around. Okay, that'd be good to know. But what are some points on it? That's also really good to know because by accident, you might stretch it wrong, for instance, if you do it the other way. But if you just find me some points, it'll work every time. I'd start with 3, and then I'd get 0 plus 5 is 5, 3 comma 5, and then I'd find a few more points. All right, good. So now, you have another Schoology quiz that helps you practice the things I just reminded you about. I did not cover everything, but I covered a lot. If you get stuck, you should come up and ask me for help. And that's all I got for you for the review for today.